In today's lesson, we'll be looking at the substitution method for solving a system of equations. Our objectives will be to identify the steps for using the substitution method and to complete an example using the substitution method. And then we'll do a practice problem. So let's begin by looking at the steps for using the substitution method. First, you choose one of the equations and solve for one of the variables. It doesn't matter which equation you choose, and it doesn't matter which variable you solve for. Once you've done that, you substitute the result into the other equation and solve. Use the value of this variable to determine the value of the other variable. So let's see how this would work. I've given you here a system of equations. X minus 2y is equal to negative 6, and negative 2x plus y is equal to 6. Our steps say we are to choose one of the equations and solve for one of the variables. Well, let's make this as easy on ourselves as possible. I would choose the first equation and solve for this variable. You could just as easily choose this equation and solve for that variable. But let's stay with the one I've chosen at the top. So we want to solve for x. We'll do that by adding 2y to both sides. That'll give us x is equal to 2y minus 6. We're now supposed to substitute the result into the other equation. Well, this is the result right here, and we're going to substitute it into the other equation. Instead of writing x, we'll write this right here. When we do that, we'll get negative 2 times, and then we substitute it in and get 2y minus 6 plus y is equal to 6. And all we've done is substitute that right there in for x. Now we solve by distributing, and I'll get negative 4y plus 12 plus y is equal to 6. Negative 3y plus 12 is equal to 6. Negative 3y is equal to a negative 6, and y is equal to 2. Step 3 says use this value to determine the value of the other variable. And the way you do that is you choose either of these two equations you want to, and you plug a 2 in for y. I chose the second one, negative 2x plus y is equal to 6. You could just as easily have chosen the first equation. When I plugged in my y is equal to 2, I get negative 2x plus 2 is equal to 6. Negative 2x is then equal to 4, and x is equal to a negative 2. What that tells us now is that the solution to this system of equations is the ordered pair of numbers x is equal to negative 2 and y is equal to a positive 2. Let me give you another one now for practice. Here's your system of equations. You may want to pause the video, see if you can solve using the substitution method, and then come back to check your answer. The easiest way to do this one would be to solve this equation for x. So that would give me x is equal to a negative 4y minus 1. We're now going to substitute that into this equation here. Everywhere we have an x, we'll write negative 4y minus 1. So that gives us 5 times negative 4y minus 1 minus 2y is equal to negative 16. Negative 20y minus 5 minus 2y is equal to negative 16. So a negative 22y minus 5 is equal to negative 16. Negative 22y is equal to a negative 11, or y is equal to positive 1/2. We now need to substitute this into either one of the equations to find the value for x. I chose the first equation, and so I substituted my 1/2 in for y. That leaves me with 5x minus 1 is equal to a negative 16. I get 5x is equal to negative 15, or x is equal to a negative 3. So the solution to the system of equations is x is equal to negative 3 and y is equal to 1/2. Let me make sure you've kind of got the big picture here. That means that if I took these numbers and plugged them into both of these equations, I would get true statements. This ordered pair of numbers will make both equations true. You may want to practice a couple of these just to make sure you have the hang of them. I could get this same answer by graphing. It would just be harder to identify that y is equal to 1/2. So this is another method for accomplishing that same task. That's all I have for you today. Have a great rest of the day, and I'll see you again soon. Bye-bye.